InfraWorks is a great tool for model federation, combining and collaborating at an interdisciplinary level. Like other Autodesk solutions, InfraWorks can host a wide range of file formats, including files created in 3ds Max, AutoCAD 3D models and 2D overlays, Civil 3D elements and models, additional external InfraWorks IMX files, Revit models, CityGML used for hosting and transporting virtual 3D city models, DGM files supporting models created in Bentley systems, Industry Foundation classes or IFC, LandXML for raw data files containing objects such as terrain surfaces, point clouds created in Autodesk Recap or various other vendor applications, raster images, spatial data files and shape files exported from other CAD or GIS applications, relevant SQLite databases, and SketchUp files. Inside of our InfraWorks model, we have the ability to import a proposed or more detailed topographical Civil 3D surfaces. The elevations from the Civil 3D surface will replace those found inside of InfraWorks using a hierarchy, triangulating between the two terrains at the tie-in boundary. This allows designers to quickly present their proposals in context and append other discipline models such as structural steelwork, architectural building shells, and so on, aligned to new ground levels. As we have linked the Civil 3D file to the InfraWorks model, when the Civil 3D elements are developed as the project progresses, these can be simply updated inside of InfraWorks, allowing efficient and streamlined workflows to take place. Inside of Civil 3D, users have the ability to export shapefiles using the map export command. In the example shown, we're going to export the surface boundary as a shapefile so we can emphasize the road and paving surfaces. When importing into an InfraWorks model, it is generally best to categorize the shapefile as a coverage area. Users can then apply a coverage style, a material, or a color to the shapefile depending on its purpose. Shapefiles inside of InfraWorks can be used for a range of scenarios, including three-dimensional mapping and highlighting specific areas, such as land ownership and parcels, site and compound areas, contaminated land, sites of special scientific interest, safe zones, and so on. They can also be used, like the example shown, for differentiating proposed designs and various finishing types using the materials library included for assets such as roads and highways, pavements and tracks, grass verges and areas of vegetation, and more. Shapefiles can help bring your InfraWorks models to life, bring further context to your designs, and help you visually differentiate the new from the existing. Further to the application of shapefiles comes the addition of spatial data files or SDFs. For infrastructure type projects, or indeed the civil aspects of a building's projects, spatial data files allow us to include further context to our InfraWorks model. It means that we can include our line marking designs which have been accurately set out and dimensioned on the 2D plan as an overlay in our 3D terrain inside our InfraWorks model. Like shapefiles, we can export this information from Civil 3D, only this time using the map DWG to SDF command. Inside of InfraWorks, we can import our SDFs as coverage areas using the same principle as how we imported the shapefiles, only this time we can apply a solid colour as opposed to a material. As you can see, this further enhances the visual outlook of our proposed designs and emphasises once again the power of InfraWorks when putting designs into context for various project stakeholders. Here we have an example Revit model containing various street elements including traffic lights, pedestrian islands, paving and curbs, and handrailing. We can import the model into InfraWorks in one of two ways. either as it stands importing the native Revit model, or by exporting the Revit model as an FBX file and then importing this. There are pros and cons for both processes. If we import a Revit model, it is live linked and can be easily updated as and when it is progressed. It also mitigates the need for further files to be created. Alternatively, the FBX file is frozen in time but is more lightweight, aiding in navigational performance and better aesthetically, as the Revit materials will be exported as is. The model can be geographically referenced, taking into consideration the project base point and rotational spatial data. As you can see, the user will have a realistic visual representation of the proposed design, useful for both model coordination and stakeholder engagement.